Are you looking to brush up your skills in Excel, but at the same time you want to see if you can use those skills and transfer them to Pandas, or more specifically to Python? If so, this tutorial is for the newbies and for the experts, both in Excel and Python. Coming right up. Hey guys, welcome back. In today's tutorial, I want to talk to you about using a Python library called Pandas. And in this library, there's a very powerful library to actually start working with data. And what it allows you to do is allows you to import different types of data, whether it be in Excel or CSV or whatever type of format, and it allows you to manipulate that data and do a lot of cool things with it. But today's video is also for those people that want to brush up on their Excel skills, because what I'm going to be talking about is 5 major transformations that you can do in Excel and in Python. And I want to compare the two to see if one is more efficient or if you find one is more effective and so forth. Now, the one thing I will tell you right up front, in some cases with some of these transformations, it is going to take a little bit longer in Python. But the thing to keep in mind is Python is always built on scale and automation. So that is, if I can actually import one data set, I'm going to do the work once in Python, and then I can import hundreds or thousands of data sets, and I can do these transformations in a matter of minutes, if not seconds. Whereas in Excel, you have to go through every single one of these Excel spreadsheets to do these transformations. So some of the transformations I'm talking about are doing descriptive statistics on your data set. So you want to know what the mean is, what the standard deviation is, the 25th, 50th, 75th, 100th percentile, and all that other kind of fun stuff. So I'm going to walk you through how to do that in Excel and how to do that in Python using Pandas. We're also going to look at how do you actually create new data. So that is, if I wanted to derive data, how do you do that in Excel versus how do you do that in Pandas or Python? We're also going to look at a very common transformation that people use in Excel called the VLOOKUP. And that is, I want to take information from one table and I want to import it into another table based on some kind of a key. So we're going to do that again in Excel and in Python. The fourth transformation we're going to do is a pivot table, and that is something people commonly use in financial analysis or sales data or all these different areas. And again, we're going to look at both tools. And finally, we're going to plot a simple bar graph. We're going to look at specific data sets, and we're going to plot an X and Y axis both in Excel and in Pandas. And I'm just going to show you how easy it is in both. But the reason why I obviously prefer Pandas is what you can do with that data afterwards. So we're going to be using some data from Kaggle. And this is essentially sales data for real estate transactions. We're going to look at things like average sale price, we're going to look at square foot, we're going to derive new data, and we're going to do a whole bunch of fun things with it. And so you may be asking, well, why am I going to be doing this in Pandas? What's the point if I can just do this in Excel? So one of the things to keep in mind is, if you're going to do this in Pandas, you can handle literally millions of rows of data. And we all know in Excel, after about 70, 80 to maybe even 100,000 rows of data, things start getting a little slow. With Pandas, you'll see it's lightning fast, so you don't have to worry about that. The other thing is, what I'm also going to be doing is setting us up to build a machine learning model in Pandas. So in today's session, all I want to focus on is just giving you an overview of Pandas. We're eventually going to get into then how do you start taking a look at the data and how do you start profiling it to make sure that we're ready to pre-process it. That is making sure there's no errors in the data, no zeros, no null fields, and all that other kind of stuff. We'll eventually also dive into something called feature engineering, and then finally into the predictive modeling as well, but those are in future tutorials. Today is really about Excel and Pandas and comparing the two. So without further ado, let's get right into it. Hey guys, alright, so what I've done here is I've actually gone ahead and set up the Jupyter notebook, and what I've done is I've gone ahead and put in some text here in terms of what we're going to be doing today. So what I'm going to put on GitHub is going to be the completed notebook, so you can actually follow along and try this on your own if you'd like. So let's just go line by line and read what we're going to be doing. So what I'm going to do is, after we read the transformation, I'm going to do it in Excel first. And for that, what I have here is I have this data sheet or this spreadsheet. And I actually got this from Kaggle.com. So if you're not aware what Kaggle.com is, it's a great website for data scientists to go on there, or data analysts for that matter, to go on there and have some friendly competition. Some of them are paid, some of them are not. But they also have a lot of good free data sources and data sets there. And so this is one of the real estate housing prices data sets that I got. All of these sales that you can see are based out of Washington. So some information here is this is the sale date, the purchase price, number of bedrooms. So these ones are all fairly intuitive to understand what these are. Now, for the purpose of today, like I said, we're just going to be comparing how we're going to process this information and the transformations that I've identified between Excel and Pandas. However, just looking at the data set as it is right now, there's a lot of pre-processing that I would do if I was going to put this in some kind of a machine learning model. But that is for a different tutorial. So let's go back to our Jupyter notebook and let's see what kind of information we have in there in terms of what we want to do. So first things first is I want to go ahead and import the Pandas library. And the Pandas library, like I said, it's a very powerful library that data scientists use. It's a great way to visualize, to look at your data, bring all your data set in, do manipulation against your data, import, export data, and then also add on other libraries on top of it like Seaborn. And Seaborn's a great visualization library. So if you want to look at certain statistical plots, or bar graphs or histograms and all that other kind of stuff, Seaborn's a great tool. There are other tools as well, but for the purpose of today and to keep this simple and to compare directly to Excel, I'm going to just use these two and that is it. So let's go ahead and bring those in. And so now we're going to import the data file. So I have the data file set up in the same directory, and it's just called data.xls. And so when I look at this is just called data.xls up here. It's in the same directory as the Jupyter notebook, so importing this in is going to be quite straightforward. To do that, all we would do is we would initialize a variable and call it data frame, and in that we would do pd.read_excel. Now .read_excel is a built-in function within Pandas, and as you see in the notes, if you want to bring in a CSV, you just write read_CSV, but this is called data.xls. Alright, so now the data is actually brought in, and so if I wanted to go ahead and look at the data, I just go ahead and run this function, and this is the same information that we have in our Excel spreadsheet. Now let's say I didn't want to bring in all 4,600 rows because that's how many data sources there are. Let's say I just wanted to view the data. I can actually do a command called df.head, and what that does is that will by default print the top 5 rows here for you, just to give you a sample of what the data looks like. You can put in whatever number here. You can put 3 in, rerun this, and then you will get 3. If you want to put 10, you can do the same. So this is just to make sure that your data set looks fine and the columns have come in correctly and so forth. So this is just to give you that visual. Alright, so I'm going to go ahead and clear this just because I don't want a lot of clutter on the screen. Now, in some cases, you may notice, depends on, for some reason, I don't know why, this computer, it's working fine. When I did it on my other computer, I was getting my data type here. These were all coming in scientific notation. And if you just wanted to correct that, I mean, there's no harm in us putting this here anyways. But if you wanted to go ahead and correct that, you would just say, if it's the price field that I'm worried about, I would just say df.price is equal to df. And then here I would write something like as type int 64. So all this is saying is just convert everything into an integer, so I don't have to worry about decimal places. And that also takes care of your scientific notation as well if your computer is displaying that. For some reason it didn't display it right now, but it did before. But anyways, it is what it is. Alright, so the first transformation I want to do is I want to get some descriptive statistics on all of this data here. So descriptive statistics will do things like it will go through all 4,600 rows. It'll give me things like the mean price for this entire data set. It'll give me the mean number of bedrooms, bathrooms, anything that's numerical. It'll give me the, generally it'll give you the minimum, the maximum, the average, the standard deviation, and a few other metrics as well. So we're going to go ahead and do this in Excel first. So just flip over to Excel. So in order to do that, you have to have actually something called your data analysis pack installed. So to do that, you would just go to your data tab, your tools tab, you go to Excel add-ins, make sure you add in analysis tool pack. Okay, solvers for something else, we don't need that for this, but analysis tool pack. And what that's going to do is when you go to your data field here, it's going to add in something called the data analysis widget up here. When you click that, you go under descriptive statistics. You hit OK. It's going to ask you a few questions. What we want are the summary statistics with a 95% confidence interval. All right, you don't need this stuff. You can bring it in if you want, but I just want to see the summary statistics. So when I hit OK, now this takes a little bit of time to generate just because it's going through 4,600 rows of data. And I'm not going to fast forward this because I actually want you guys to see how long this is going to take. And there you go. So Excel actually threw an error, but it ended up doing it anyway. So when I look at this, it looks at mean for, and again, for things like date, it doesn't mean anything. So you can just ignore it. But for price, the average price for this entire data set is $551,000. Standard error is 83,000. When I look at the minimum is 0. Now again, if I'm building a machine learning model, that's one of the first things I look at to see if there's any zero values, because a 0 value for price doesn't make a whole lot of sense. That just means it's probably the data is has an error in it or something like that. But for this purpose, we're just going to leave it in here because we're not doing any of that. We will focus on that in an upcoming tutorial. All right, so same thing with bedrooms. The average bedroom size here is 3.4. Bathroom. So this gives me a good overview of my data, right? Most importantly, what I want to look at, especially when I'm looking at completeness of the data, is everything has 4,600 counts. So that means that it has data in there, whether it's like an NaN, for example. I think that would get counted in Excel as in the count function. But that's one of the first things I'll look at to see if I'm not missing any data. So if I'm looking at scenarios where I've got 4,600 rows for price, but I've only got 500 rows for square foot, I'm going to be a little suspicious around that, and then I'm going to ask myself, what do I do with this metric? Do I get rid of it? Do I try to upsample it? So there's a whole bunch of different techniques you can do, but we'll talk about that later. But again, this is to give you an overview. So that's how you do that in Excel. So how would you do that in Python? So when I go here, I type in df.describe, and look how fast that was. So Excel almost threw an error and almost died, but this didn't. And so this is still giving me, 551,000. It actually took out things like the date because the date doesn't really mean anything, whereas Excel actually left it in there. So if you see, it's still got the date function in there. And I think the rest of it should be okay. But I mean, 551,000 is the mean. Standard deviation's 563,000. And so this is kind of giving me the same information, but you saw how quick that was. And I promise you, whether this is 4,600 rows of data, 46,000 rows of data, or 4 million rows of data, it's going to be leaps and bounds faster than Excel. There's just no competition when it comes to that as well. Okay, so that was the first transformation I wanted to go through, is help you look at a data set and say, how do you get the statistics out of it, just to get an overview and understanding of some of the data behind it as well. All right, so the second one is, now I want to derive a calculated field, price per square foot, in Excel and Pandas, and sort by that derived field. So essentially what I want to do is I want to tack on another variable right here. And what I want to do is I want to take the price and I want to divide it by the square foot of the lot. Okay, for every single one of those rows, and then I want to go ahead and sort by that specific new variable that we're going to do. So let's go ahead and do this in Excel. All right, so I'm actually going to, I'll leave that, I guess. All right, and then you also may be wondering why I have two different data sets here. So data and data for analysis are the exact same. I'm going to be using data for analysis to do all my manipulation because I don't want to import that data into my new data frame. I want to just leave the original data so that I can manipulate this on my own. So we're going to use data for analysis, okay? And so all I want to do is I want to go ahead and add in, so we'll call it price, and this just means square foot. So price per square foot. All right, so we're just going to do this, which is my price, divided by, I said we're going to take for the entire lot. And so that gives me that value. And nicely, this is already actually sorted by this column, so that works out for me. All right, so essentially this is saying that for this specific property that sold, 219th in Kent, Washington, sold for roughly $3,412 per square foot. It was a 3-bedroom home, 2 bathrooms. I have only that much living space, so that's interesting. So that means it's a very small house on a very big lot, so should have a pool and a big backyard. But anyways, I digress. All right, so that actually wasn't very hard to do. I mean, for some reason, I don't know why this sorted. It generally shouldn't. But if I did want to go ahead and sort that, you know, I would just go here and I would just hit sort, and then I would pick that column and go largest to smallest. All right, so that's how you do it there. So now let's go ahead and do that in Pandas. So here, I'm going to introduce a new variable. We're going to call it df. So we're going to call it the same thing. All right. And it's just going to be derived based on taking df price divided by df, it was called square foot lot. All right, so now when I go ahead and do a df head on that, because I don't want to go ahead and print everything, it's just too much. You know, I have my price per square foot, and so it's just taken that, it's appended it onto this data frame, and really it's that simple, and it does it very quickly. Now, if I want to go ahead and sort this, I would just go, so I'm basically saying go ahead and reinitialize my df, reallocate it to based on this sort function that I'm going to do. So I'm saying when I'm printing this out, sort it, sort values, and we're going to do by equals price per square foot, and then I can do ascending. This is just basically saying that I want to do it in descending when I specify false. There we go. All right, so now you can see it's actually sorted by this column. Now this may seem like a little bit of extra work based on what you're doing in Excel, because Excel is, you know, pretty much GUI at the end of the day. But again, think repetitiveness, think scale, think about doing multiple files, think about doing large files. But anyways, we'll talk about that a little bit more in a few minutes. All right, so now I want to do is I want to find the count of sales and mean price in each city by bedroom. We'll accomplish this by doing a pivot table. All right, so everybody loves pivot tables, right? So here's what I'm talking about. When I go back into Excel, so I remember doing this before. I forgot how to do it, I forgot what the instructions were exactly, so I'm just going to paste them here so that I know. So I think what I was telling myself to do was find the count of sales and the mean price. So I want to know how many sales and what the mean price was by city, by bedroom size. Okay, so we're going to first do this in here, and then we'll see how we do that in Pandas in a second. All right, so to do that, we're going to go to data. We're going to go to summarize with pivot table. The other thing is, if you ever forget where this stuff is, because I remember back in the day when I used to use an older version of Excel, things were in a different place. You can always just go to help, type in something like pivot table, and then it'll actually just point you to where it is, and you can just click it from there. That's just a small little tip. So you want to make sure your entire data size is in there. Click OK. All right, so what we want to do is so we know that we have to bring in city. All right, we're going to be bringing in bedrooms, and we're also going to be bringing in price. Okay, so these are the variables I know. It's not arranged how I want it right now, but these are the variables that I need. All right, so first and foremost, what I want to do is on the rows, I actually want to bring in city. So let's move city over there. So now that I have my city over here, I want to plot my bedrooms up top here. So the number of bedrooms that I have. So we'll put that under columns. All right, so now that I have summer price, I don't want summer price. I want to get, first of all, if I were to just do count of price, so that's the equivalent of me saying how many sold in that area. So that basically says that in Algona, for example, there were two houses that sold that were 4-bedroom. But now I also want to know, that's good information, but now I also want to know, well, how much did they sell for? What was the average price for that 2-bedroom home if there was, you know, for those 2 bedrooms that sold? So I'm going to bring price down here again under values, and I'm going to change this to average. And these are side by side. I don't want them side by side, so I'm going to flip this upside down here. And what this gives me is, in Algona, I had 2 homes that sold that were 4-bedroom for an average selling price of $255,000. Okay, so that's how you read this. And you know, you can manipulate this however way you want. It doesn't really matter. But what I'm trying to do is I want to say, how do I take something that is, I wouldn't say this is a complicated pivot table, but it's still something that, you know, is somewhat complex. how do I view this information? So then you may be asking, all right, next question is, well, how do we do this in Pandas? All right, so Pandas actually has a function called pivot table. So I'm going to define a new variable. We're going to call it df_piv for data frame pivot table. And I'm going to say pd.pivot. We're going to define where the data is coming from. So it's coming from the df data frame, which is right up here. Now we're going to define the index. And the index is essentially the same as what is going to be on the right-hand side in this case, which is going to be city. Right? So this is the equivalent of the index right here. So I'm going to define my index as equal to city. And you have to put this in a list format because you can define multiple variables within an index. So you can have 2 variables just like how you can in Excel as well. So we're going to put this in a list. All right, now we're going to say values. So what are the values that I want to print? So you're going to see something a little bit confusing here, but just hang tight and I'll explain it. I'm going to say price. And then I'm going to say price again. And the reason why I did this is the first price is going to be the count. The second price is going to be the average price, right? Because remember when we did this in Excel, we brought in price twice here. One is the count, one is the average. So we're doing the exact same thing here. And the column that I wanted to display on the top was, I think we picked bedrooms. All right. Now we're going to define something called the aggregate function. And what that basically means is when I'm looking at these specific values, what do you want me to do with them? So in the first case, I want you to count them. And then in the second case, I want you to do the mean, just like how we did in the other one. So it's going to give me the average price. All right. So let's just print this out, see what it looks like. And this should be equal to, not plus. And of course, I'm going to get an error because this is supposed to be columns. All right, and I got another error, and the reason is this is actually supposed to be called pivot table. Just like in Excel, pivot table, pivot table. All right, so it actually did something, which is cool. So let's view this and let's see what it looks like. So this is what this entire thing looks like. So we're going to take care of this NaN in a second, but we have our price. So we have the count of the price, which is essentially how many homes were sold. So again, in Algoma 4-bedroom, we saw there was 2, and the average price was $255,000. So we know it's bringing in the right information, but that's how you do a pivot. Now, if you want to get rid of these NaNs, you can just fill it with a default. So fill actually means if I do get a like something that's an NaN, what do I put? So in this case, if we just put a 0, and if we rerun this, you see that it's all gone to zeros. All right, so it almost looks, if not identical, to the Excel version here, except we only have blank spaces here, which we can do there as well. But let's just do another validation here. So let's look at Seattle, 688 homes sold that are 3 bedrooms, and the average price of a 3-bedroom in Seattle is $563,000. And so when I go ahead and look at this, and I go down to Seattle, 688. $563,000. So we know that it's actually doing the right thing. And again, you don't have to bring the whole thing here. You can do the head function here as well. There's another function called tail, and what tail does is it shows you the last 5 rows. Right? So it'll actually show you the bottom 5 rows, and you can specify again, if you want the bottom 10, you just do that. But you can use tail, you can use head, it doesn't matter what you use, but that sort of gives you that. So that's how you do a pivot table in Pandas. Very simple and straightforward, actually. And I find the pivot table in Pandas is a little bit more intuitive. Now, I obviously am a little bit more biased towards Pandas, and that's just because I use this on a regular basis. But when I look at this, I mean, it's just so much more intuitive to say, all right, on my left-hand side is going to be my index. The column on the top is going to be bedrooms. And in between, I want you to do this on price and price. One is a count, one is a mean. Done. That's it. That's just how simple pivot tables are. And you don't have to worry about this thing throwing an error. Whereas in Excel, if you're doing a pivot table on even, 200,000 rows or 100,000 to 200,000 rows, you're going to be waiting there for a while. You can go get a coffee and come back. Whereas here, it's going to be near instant. So that's the other benefit as well. All right, so now let's move on to transformation number 4. So what I've done here is I've created another sheet in this Excel spreadsheet. And what this sheet does is it's called city and it's called average appreciation. So I made these numbers up. This does not come with the Kaggle data set, but essentially what this means is in the last 5 years, Kent had an average appreciation of 10%. Kirkland had it of 5%. What I want to do is I actually want to go ahead and bring that into my data set here. And in Excel, it's fairly straightforward. You would do something called the VLOOKUP. And so I want to show you how to do a VLOOKUP in Excel and how to do one in Pandas as well. So it's very straightforward. So if I were to just give this a title and call it average that appreciation, I would just do VLOOKUP. I would go ahead and copy the city name, comma. The next thing is saying what's the table array that I want it from. Well, this is my table array here, and I want to get field number 2. And so it'll actually bring back 10, right? So because these are all saddle, you see all of these are 9, but if I scroll down and I see whatever that is, let's not pick that. If I pick Belleville or Belouve or however you say that, it's 6%. If I look at something like Sammamish, it's 5%. And so when I go here, Sammamish, if I can find that here, wherever that is, right there. So it's 5%. So it is bringing in the right field, so it's appending it on here. And you can do this, you can use this for some calculation. You can say, what do I predict the average price to be next year based on an average 10% rate? You can discount that, or you can normalize that to 1 year and say, how do I apply the math to it to this price here to say what I'm going to predict it to be next year, as long as it's, assuming it's a straight line regression here. So now the question is, well, how do you do that in Pandas? I want to be able to take this data set here, this data frame, and I want to append onto the end that value. So the first thing I got to do is I got to import that data because it's sitting in a completely different sheet, right? And I purposely did that because I wanted to show you how you import something that has a completely different sheet name. So right now, it's importing the data that is the first sheet. So I should actually move that over. It's importing data because that's the first sheet. Now, if I want to make sure that it's always importing data, I can just go ahead and actually get the sheet name, which is City AA. And so I will do something like this, where I will say df appreci or appre is equal to pd.read_excel. I would say it's in the same Excel file, but I would go down here and say sheet name is equal to City AA. All right. So what I want to do is I want to go ahead and print that out. So let's see what that looks like. So when I print that, it just brings in that same sheet over there, the same VLOOKUP sheet that I made. All right, so now the question is, well, how do I go ahead and do this VLOOKUP? Actually, the VLOOKUP is very straightforward. So I'm going to create a new data frame, which is going to be the data frame that includes the VLOOKUP, and I'm just going to call it results. And I'm going to say results is equal to, so there's another function called df.merge. So merge will take two different data frames. It'll add them together based on a key. So I would say df.appre, appre, whatever you want to call that. And then this is the equivalent of me saying what I want to actually go ahead and do it on. And I want to do it on city. So here's what this is saying, is take my data frame, so my first data frame, which is called df here, merge that data frame with this new one that I just brought in, the df.appre, and then do the linking based on the key city. All right, so now I'm going to run this. Hopefully no errors. Good, no errors. And now let's see what this data set looks like. So I'll just do this. Now when I scroll over, it actually has my average appreciation. All right, now because again these are all Kent, it's going to bring in 10, but we're going to do some validation against this right now. So to validate this stuff, let me just add in another column here, or another. All right, so to validate this, I'm just going to add in another block here. I'm going to say results, and there's a feature in Pandas called lock. What lock is going to do is it's going to iterate through your rows. So what I want to do in this case is I want to do results.lock. I want to look at my column called city. All right, so to do that, I'm just going to do results and then city. And then I'm going to say that's equal to, so let's test one out. Let's go ahead and test. I took that away, so let's go back in Excel. Let's look at this one that's -5. So Inglewood Finhill. So I'm just gonna copy and paste that. I'm gonna say make that equal to whatever that was. So we're gonna put that in quotes, and then we'll print this out. All right, so this here is equal to -5%, which is what we saw. So there's only one sale for -5%. All right, so let's go ahead and look at Clyde Hill, because I want to make sure you guys understand how this works. So if I want to go search Clyde Hill and validate that, Clyde Hill is 10%, which is what we saw. So there's a whole bunch of them. All right, and let's just do one last one for complete confidence here. So we're gonna do Medina, which is -4. So we should see -4 here as well. So when I go down and I do this on Medina, I get -4. So that's essentially how you do a VLOOKUP, and you bring in another field. So far we've worked through 4 what I would call major transformations that we would do in Excel, and these are very, very common, extremely common. If you're talking to any kind of an analyst, somebody has definitely used one or more of these for sure. All right. Now the last one I want to do is I want to go ahead and plot the average price per square foot by bedroom using a bar graph. Okay. So what this is going to look like is along the bottom, if I just have a graph here, so let me just draw something here. If I have a graph here, along the bottom here, I want bedrooms. And then here I want the average square feet, or price per square feet, sorry. You're gonna have to excuse my writing here. I'm doing this with a mouse today. And then I want to know for a 1 bedroom, what's the average price, for a 2 bedroom, what's the average price, and so forth. And I should see something very similar to this, but that's essentially what I'm trying to get to. All right, so let's go do this in Excel first. All right, so when I go back to my data for analysis, what I'm going to do is I'm going to go to data. I'm going to go to insert. I'm going to go to pivot chart. And pivot chart is just a little bit easier to use. But what we're going to do is on the y-axis, we're going to look at price per square foot. So I'll bring that into values. Then on the x-axis, I want to see bedrooms. And so this is essentially what I was trying to get at. All right, so this is actually looking at the sum of the price. I want to go ahead and change this to the average. So I'll go to average. And so what this tells me is that, again, this is an error that we're going to have to deal with later on. So I'm going to ignore that for now. But for a 1 bedroom, the average price per square foot is around $89. For a 6 bedroom is roughly $105. All right, and then when you get to an 8 bedroom, it's $177 a square foot. And then surprisingly, when you get to 9 bedroom, it's $86 a square foot. Okay, so I want to replicate this exact same thing in Pandas. Now, in order to do that, we're going to leverage something called Seaborn. And Seaborn is an extremely powerful visualization tool. And to bring that in, we're just going to do import Seaborn as SNS. If you don't have it, you can just go to your terminal, type in pip install Seaborn. And if you don't have Pandas, pip install Pandas. It's very simple to install both of them. Okay, and we're just scratching the surface with Seaborn. Trust me, when we get into some of the machine learning modeling, I'm going to show you some really awesome plots. But for the purpose of this, let's just keep this very, very simple and draw this graph here. Okay, so what I'm going to do is I'm just going to specify a name. I'll call it, graph, and we'll say that's equal to. So you're going to do something called SNS.barplot. We're going to say on the x-axis we want bedrooms, not in caps because it is case sensitive. On the y-axis, price square foot, and I just realized that should be little x, not big X. There's a whole bunch of other things you can add here. So the data that I'm going to be relying on is my results data set, which is the one that I just created here. And then just for fun, we can, paint or color this stuff, different palettes or colors. I like something called blues_D. I've just used it quite a bit and I like it. And so let's go ahead and graph that out. So this is what it looks like. All right, and the other thing is if you want to get rid of these little error graphs here, you can just go in here and type in error width is equal to 0. and that just will get rid of those little things. I actually don't like them. Here's another cool thing. When you're in Jupyter Notebook specifically, you can actually hit, on a Mac, it's Shift Tab. I don't know what it is on other ones, but as soon as you hit that, it'll actually tell you what kind of arguments this will actually take in. So it'll take in an X value, Y value. You can change the hue, but the hue is going to be for a third variable, which we'll talk about another time. The data in this case is the results. You can order this in different ways or by different columns. Confidence interval is 90%. So there's a whole bunch of default values in here, okay? And I generally don't touch these. The only ones that I really touch are the ones that I put on there, or I'll add in something like hue, but we'll talk about that another time. But really, that's how simple it was. So when I take a look at this spread, or this graph here, it's almost identical to this one here. So it's telling us the same thing. So for one bedroom home, it's roughly $140-ish or so. Again, my 8 bedroom is the highest, just like this is saying, followed by my 9 bedroom there. So these are some of the transformations that we can do with Excel versus Python. What I want to leave you with is, if we had another version of this data, so let's just say that, we had a refresh of this data and we wanted to apply this in a different file. So what I mean by a refresh of the data is you get an entirely different data dump, but you get it for a different city. Okay, and you can append that to the bottom here, but in Excel you're gonna have to do a lot of manipulation to just isolate Washington again, for example. So if I had it in California on the bottom, with Excel you're gonna have to go back and adjust all the formulas. Sometimes your formulas are hidden within cells, and we all know we've used Excel in the past. It's kind of a painful process. Here, all you have to do is change the data file, hit run all, and you have this entire thing done for you in minutes, if not seconds. If you wanted to filter out just for California, you can just go up here, or sorry, just for Seattle, you can go up here and you can just say drop anything that has California as a state. And then you have your entirely new data frame and you're good to go, you're ready to rock and roll. So these are some of the basic transformations that we do in Excel and in Python. Hopefully you guys found this very, very useful, and that wraps this one up as well. All right, and that is it. It's really that simple. So Pandas is a very, very effective and efficient tool to use. Excel is great, don't get me wrong, but the things you can do with Pandas, the speed you can do it with, the ease you can do it with is just unprecedented. It's very hard to compare to. And again, like I said, while you can do basic regression models in Excel, like linear regression or maybe a polynomial regression or something around those lines, I can use the same tool like Jupyter Notebooks, use part of Seaborn, for example, and at the same time use Pandas to do very, very sophisticated machine learning modeling. Now, when you're talking about machine learning modeling, you're really talking about either classification or regression models. And so the one we're going to focus on in the upcoming tutorial is going to be on regression, but I will get into classification as well. And we'll probably do it with something like a random forest classifier and a neural network as well, but that's for the future. But really today's video was to set the foundation for you so that you can play with this information as well. Now I'm going to put the code up as well as the test data set up on GitHub, so you can go down, look in the description. And again, if you guys found this helpful, please comment, like, subscribe, and share, and I will see you next time. Thanks very much.